when you promise something. Yeah, it means that you're not going to do it. Yeah. Yeah. But it also means that you're like hoping that something will happen too. It's weird. Yeah, it's weird. The old fingers crossed. All right, here we go. That is a great 15-second introduction to today's lesson on the video. So we're talking algebraic expressions today. So before we start with algebraic expressions today, we should probably talk about, we're going to talk a little bit about properties and evaluating powers and all that fun stuff. Okay? Notes for today. Notes are totally on your own. There will be some stuff that I say, make sure you write this down this year. There will be some stuff where I say, don't write this down. And there will be some stuff where it's going to be up to you to write it down. Okay? My rule of thumb always is, if you're looking at something and you are seeing pops and buzzes and it's not clicking for you, you should write it down. Okay? Right? Because the first thing that I'm going to tell you in a couple of weeks, when I check everybody's grades, we have a little conversation, is I'm going to say, what you're taking for class, you know what I mean? And that's going to be the key then going forward. So just so you know. Okay? Again, as I told you before, if you got a notebook, that's great. If you got a 3-ring binder, that's even better. But you should have one just for this class. Okay? All right. So this first slide is going to be a bunch of properties in algebra. Again, this is going to be one of those slides where I don't care if you write it down or not. Okay? You know all of these properties. Okay? I promise you, I guarantee you, I'll pinky swear that you know all of these properties. So there's no need in writing them down. I'm just refreshing memory with this slide. Okay? So the first property that we are going to talk about, or the first property that we're going to need, and now for these properties, there's an addition component and a multiplication component. Okay? So the first one is called the commutative property. And the commutative property tells us that order doesn't matter in multiplication and addition. Okay? It tells us that 2 plus 3 is the same as 3 plus 2. It tells us that 7 times 4 is the same as 4 times 7. That's what the commutative property tells us. Again, I am not going to ask you on a test or a quiz what is the commutative property of addition, but I do expect you that you know this stuff. Yep. Because you've been doing this stuff since you were in elementary school. Next one is the associative property. Okay. The associative property tells us that, let me move that up so everybody can see it. The associative property tells us that if we have multiple things going on, again, order doesn't matter. 7 plus 8 plus 9 is this. So if you add 7 and 8 first, you can do that. Or if you add 8 and 9 first, or if you add 7 and 9 first. Doesn't matter what order you take those in. You'll get the same answer. Next one is the identity. Okay. The identity for addition says that when we add 0, nothing changes. When we multiply by 1, nothing changes. Okay? So that's what those are. So the additive identity is 0. The multiplicative identity, and the only reason that that one's on there is because I love the word multiplicative. Okay? It's my favorite. Okay? Okay? So the multiplicative identity is that. The other side of that coin, okay, is inverses. Okay? So if I add two inverses, two additive inverses together, I get the additive identity, which is 0. 4 plus negative 4 is 0. Okay? If I multiply inverses together, I get the multiplicative identity, which is 1. 4 times 1/4 is 1. And lastly, our good pal, the distributive property, where if we have a number or a term out in front of a set of parentheses, we multiply that into every single part inside the parentheses. Now, I will tell you that as a 46-year-old father of two who's been teaching math longer, I've been teaching math at WASOS longer than you've been alive, I still, to this day, draw in my humps. Okay? Right? It's okay to draw in your humps. Because that reminds you, oh yeah, it's got to go into every single part. Okay? Not just the first one, it's got to go into every single part inside the set. Okay? So if you are a hump drawer, you draw them humps. Okay? Okay? So let's talk a little bit about the difference here now between an expression and an equation. Okay? An expression is just numbers and variables, so numbers and letters and operations. Adding, subtracting, multiplying, dividing, squaring, cubing, square rooting, all that fun stuff. Okay, so that's all it is. Okay? It can only be simplified. Okay? An expression can only be simplified. That's it. Okay? It can be simplified, which means simplification could mean you combine like terms. Simplification could mean you need a factor. Simplification could mean you can multiply it out. Okay? Those things. That's it. Okay? You can only simplify an expression. An equation is different. An equation has an equal sign. That's the key. If it says something, 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 something equals something, 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 that's an equation. If it's just something, 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 expression. Okay? Simplify. Equations, that's what we solve. In the very end with an equation, we want, for instance, x equals some number, or x equals 2 numbers, or x equals 17 numbers. Okay? We want, in the end, that's what we want our equations to look like. We want to solve. Good quality H2O. Oops. Whoa. Whoa. Now it's way over here. Oh, just wanted to see if they're there. Oh, this side. Powers. Okay. The kicker when we are dealing with exponents and powers is that I'll put it in the green, is that the exponent only controls what? Is in front of it. So you're going to have a thing called a base, and that base is going to have an exponent. So that exponent only controls that base, what's directly in front of it. Okay? So I will tell you that 3 to the 4th is like 3 times 3 times 3 times 3. 3 times itself 4 times, right? Which is 9 times 9, that associative property, which is 81, right? Okay. So 3 to the 4th power is 81. you now figure out for me what these other ones are. Okay. Figure out what those other 4 are. Wrong. I did, but this one here is negative 81.
Wait, what is
I think that's 2.
Nope. Number 2 is 81. Or excuse me, C.
Wait.
Talk to me. That's okay.
Oh, wait.
So what's directly in front of the exponent? No. 3. Okay. For the B. B. So this one here, I did it in purple. This one here is, we've got that negative sign, and then it's that. That this one is negative 3.
Oh, that is so.
Okay? Because that 4 in B, the exponent, is only controlling what's directly in front of it, and what's directly in front of it is just the 3. Until I put parentheses around it like in C. So there. Yep, right there. So this one is negative 0.7. So is this one. Questions, comments, concerns, clarification?
I feel like you were tricked.
Yeah. Evaluating expressions. I call it the plug and chug method. So we're going to take this 3. And we're going to put it in to every spot that there's next. Three squared is 3 times 3, 3 squared. 9 times 4, 36. 2 times 3, 36 minus 6 plus 3. 33. Okay. You try letter B. You can sit wherever you want. So 8 times negative 2, that's what? Negative 16. 2 times negative 2 is negative 4. Negative 4 minus 9 is negative 13, right? Negative 13 cubed. I didn't distribute anything yet. I combined like terms first. Parentheses comes before exponents. PEMDAS. 13 times 13 times 169 is 2,197. Yep. And then plus 4. Right? Agree? 2 times negative 2 is negative 4. Minus 9 is negative 13. Cubed is negative 2,197. What plus? Better? Yeah. So negative 16 plus negative 2,197 is negative 2,213. Right? Minus negative 4 is like plus 4. That gives me negative 2,209. 2 times negative 2. Well, so that's why it's plus 4 again. What do you mean? Which one? Purple or blue? Blue? Yeah. But so it's minus negative 4. So I did these and kept the minus sign. You could have also just written it as plus 4 and done negative 2 times negative 2. Love it. PEMDAS. Okay, as you can see, we'll be using PEMDAS. I love it whenever I see on like postings on the Facebox or the Snap of people doing like, what answer do you get to this one? And then everybody gets it wrong, you know. And so, because they work everything left to right. Not everything is not left to right. So the first thing that we do is parentheses. I think that's how you spell it. I'm guessing. Oh, I think that's right. Okay. And then we got E. E is for exponents. Okay. Then we got M and D. M and D we do at the same time. That's multiply and divide. And that one we go left to right. So we're multiplying and dividing, we work that left to right. And then at the very end, at the very last, we do adding and subtracting. Again, that is done at the same time. Again, that is done left to being said, try those three. Find me what you get. Evaluate those three expressions, A, B, and C. All right, here we go. So first, oops, come on now. There we go. So first one, I got to do parentheses, PEMDAS. So parentheses, 4 minus 2, that is going to combine to be 2. So this gives me 3 minus 2 times 5. 2 times 5 is 10. 3 minus 10, I got here negative 7. Do we concur? Yes? Okay, love it. On B here, we're going to do the parentheses first. The parentheses, then we have exponents inside the parentheses. So we have to do that part first. So this is really 4 plus 3. And then 4 plus 3 is 7. Now we've done parentheses. There are no exponents left over. Multiply and divide. 21 divided by 7 is 3. Then minus 10. This one I also get negative 7. Do we agree? That's the thing that we're agreeing. Okay. Number 3, or letter C, I should say. Okay. So the first thing that I'm going to do is I am going to do this whole conglomerate at the same time. There's no parentheses, there's no exponents, so I'm going to do multiplication and division at the same time, left to right. So this is 4 divided by 2 is 2 times 6, oops, not times 16. Come on, Linsmeyer, you're better than that. Times 6 is 12. 3 plus 12 is 15. Do we agree on that one? Okay. I do that whole purple conglomerate all at the same time because it's both multiplication and division. Okay. Love it. I want to say that there is one more. Combining like terms. Okay. So combining like terms is just that. If a term is exactly alike, meaning it's got the same letters, it's got the same exponents, everything is the same on it, we just add or subtract the coefficients. Now, coefficient, that's a big word. Coefficient is the number out in front. Okay? So, for instance, I would look for any other x cubes. Well, there's one more x cubed over there. So if you got 9 of them, and I take 5 of them away, that leaves me with 4 of them. So it's 4x cubed. The variable does not change. Just the number of the variable changes. Then we look for the next one. Here's a squared term. There's a squared term. You got 2 of them. I got 11 of them. Together, we have 13 of them. And there's nothing else that combines with the x because we got everything else. And so there is the simplified version of it. Don't be one of those people that then gives me 13x to the 6th power or 13x to the 5th power on this. I can't add the exponents on this. That only happens when we're multiplying. Okay? distribution first. So then that would become 2x squared minus 2y minus 9x squared minus 18y. Combine the 2x squareds. That gives me negative 7x squared. Combine the two y's. That gives me negative 20y. And can't combine it. That's it on this side. Tis it. Oh, and look at that. All done. Okay? So, yep. So that week 1 worksheet that you got when you came in today, that will be due Friday at the end of your class.
When are our grading class? Like which day?
Monday? Monday. Okay? But the nice thing is I'm the only grading teacher, so grading months really doesn't matter to me. And most of the time, what I'll probably put, I'll go back to this, putting it on there is like just different funny, like kind of funny. Like, what's your favorite car? What's your favorite animal? What's your favorite, kind of deal? Because I know that, I know that it's me, so,